Okay, hello everyone. I hope everybody's healthy and we get past this health crisis. I am Ajib Mohammed, author of this paper. I am honored and pleased to present the results of my work entitled Hardware Implementation of Roadway Classification System in FPGA platform. My presentation will be as follows. First, I will begin with an introduction. Then I will continue with a presentation of my roadway classification system. Thereafter, I will present the implementation and I will end with a conclusion. In recent years, urban traffic has experienced a great evolution because of the increasing population and the number of vehicles. This has caused serious road safety problems, namely the increase in the number of accidents and the disruption of urban traffic. In order to overcome this problem and mitigate their consequences, several techniques have been used in driver assistance system. The system have attempted to improve the comfort and safety of vehicles by using two types of system. Passive system like seatbelt, airbag, whose objective is to minimize the consequence of road accident. Active system like ABS and DSP, whose objective is to avoid dangerous accidents. But these solutions are insufficient to the need of roadway safety. This push research acts around the world to look into the field of road safety, and more specifically in the field of intelligent transport. This multidisciplinary research axis combines the field of computer science, artificial intelligence, and embedded systems in order to provide intelligent solutions aimed to avoid road accidents or mitigate their consequences. The objective of this technique and algorithm is to provide information to the driver about the state of the environment, the location, and the distance between other vehicles. Since their operation, intelligent transport system aim to equip vehicles with sensor and algorithms so that the driver has a global vision of the environment through acoustic sensor and image sensor. Among the applications developed by the intelligent transport system, the following two applications can be mentioned as examples. Obstacle detection like vehicle, pedestrian, bicycle based on the image in front of the vehicle. Detection and recognition of traffic sign and recognition of vehicle license plate. The second type based on acoustic sense and powerful computer signal processing algorithm. Classification of roadway type based infraction between the pavement and the wall. Detection of private vehicle like ambulance and police. In this context, our work focused on the design of roadway classification system based on the sound emitted by tire road interaction. The problem to which this work respond are based on the following axes: the power of signal processing algorithm, real-time classification, and functional autonomy. To this end, several contributions are made to this work. Use of signal processing tool, which aim to extract adequate information from signal of the different roadway class and to accelerate this process. Combining this signal processing algorithm with a high performance classifier to design a robust and fast roadway classification system. However, the property of the artificial neural network require a powerful hardware implementation circuit. Hence, the use of a platform capable of implementing this artificial neural network and using parallelism in processing and reconfiguration. Thus, several researchers have tried to implement this network in embedded platforms such as a graphic processor and the application-specific integrated circuit. But this system have major drawbacks related to application area, such as the speed of calculation, which is a paramount parameter in the field of roadway or road safety. For this, the work will be deducted to the implementation of roadway classification system in the FPGA platform of Cyclone 2 Altera. Now, we move to the design of roadway classification system. To do this, our roadway classification system will follow this architecture. or an input signal. This signal goes throughout a segmentation phase, which consists in dividing the signal into pieces of the same duration, then throughout a description phase, and finally throughout a classification phase. After seeing the different phases of our proposed system, I will detail the objective and algorithm used in each phase. We're starting with the description of the signal that has the objective to extract a feature for this signal. For this, we used the DWT that have an objective to separate or decompose the signal into two components represented: the general shape of the signal, named the approximation, and the data of the signal. To decompose the signal, we use two complementary filters: a low-pass filter and high-pass filter. Thanks to mutual resolution analysis, the approximation of the first level can be decomposed again in order to extract the approximation and data of the second level, and the process is repeated until the desired level of decomposition is reached. Therefore, the extracted vector is the concatenation of all the data with the last level approximation. Now, classifier that have a goal to classify the feature vector into four classes. This class is asphalt, gravel, snow, and stone road. That means the type of roadway. We use for this the artificial neural network. The artificial neural network is a treatment process information that is inspired by the way biological nervous systems such as the brain process information. This process is based on a large number of processing united neurons. These neurons interconnect them to form an architecture dedicated to a specific application such as pattern recognition or control. These neurons are based on activation function to guarantee the non-linearity in the network. The most commonly used activation function is the sigmoid function. In order for the artificial neural network to work for any application in the field of artificial intelligence, it requires a learning process. This process consists of adjusting the connection weights between neurons called synaptic weights. The architecture of the artificial neural network most commonly used in the literature is the architecture of multi-layer perception, to be adopted in our Roadway classification system. Now, we move to the implementation. For this, we use the FPGA. FPGA are integrated circuits that offer an inexpensive, easy, and flexible solution. The FPGA is used for the implementation and design of complex circuits and complete digital systems on a single chip. The FPGA have a lot of advantages and some disadvantages. Possibility of prototyping, low time to market, adaptability to future evolution, and flexibility, and the parallelism of processing. Disadvantages: limited integration by research and high unit price for large production. Now we start for implementation. Our implementation used three models: data and command generated model, DWT model, and artificial neural network model. The first model, data and the command generator model, have a goal to synchronize the discrete wavelet transform feature extraction process with the classification process, generating a wide range of signal. For example, it have a lot component, a set of RAM memories to storage the information, an address and command generated, a ROM memory of the synaptic weight of the artificial neural network. Now, for this, we start by reading the signal to be processed from the SD card, generation of the control and synchronization signal of the DWT model, generation data of this block model, and storage the vector provided by the DWT calculation. The second step is to generate this vector DWT data vector to the generation, the control and synchronization signal for the artificial neural network, generate the data for this block, and storage of intermediate data, the hidden layer provided by the artificial neural network. The second block is DWT model that have a goal to materialize the feature vector extraction processed by DWT. That means the hardware description of the approximation extraction equation and the extraction equation of the data of each level using the mega function block of Altera. This addition and multiplication block manipulates real 32-bit floating point data. And now the last model is artificial neural network. The implementation of artificial neural network, we start first with the implementation of the formal neuron. This implementation consists in materializing the following equation, which require a wide summation, and then the calculation of the sigmoid transfer function, which require complex mathematical operations such as division and exponentiation. Thereafter, this formal neural and the command and generator model will help each other to accomplish the work of artificial neural network. And finally, here we have a schema RTL just of my Roadway classification system. Conclusion: the proposed Roadway classification system has collected performance algorithm in signal processing and in terms of artificial intelligence. Our paper had as objective to implement the Roadway classification system in FPGA platform in order to show the performance of this implementation in terms of execution time and hardware resource use. And thank you.